There are numerous job opportunities in the field of data science, which has led to an increase in people aspiring to become data scientists. Many believe that one needs to have a degree in statistics, computer science, or engineering to pursue this career. However, even those without a technical background can pursue a career in data science by following the right path of learning. This video focuses on the data science process and guides you towards your goal of becoming a data scientist. To become a data scientist, it is important to understand the data science process. What is the role of modern data scientists? How have they created AI applications that we use in our daily lives, such as face tagging, Alexa, autonomous car? Additionally, how do business utilize AI? For example, Amazon has their own recommendation system for product sales. Banks use AI to detect frauds and issue early warnings. And even government use AI for surveillance and traffic monitoring. The applications for AI are numerous, and modern data scientists have played a key role in developing them. So let us begin our journey by first understanding the data science process. There are two types of data in the world, numeric and character-based. A database table may have both type of fields. Character-based data can also be found in text document. When analyzing data with machine learning, it can come from various sources such as relational databases, structured or unstructured database, or even NoSQL database. A data scientist may need to work with large text collections like news, articles, or novels. Data pulled from the web may include HTML tags. Additionally, image dataset may need to be analyzed by the data scientist. When it comes to processing data, whether it's numeric or text-based, different methods are required. For the purpose of this discussion, let's start by focusing on numeric data. When developing applications, numeric data is used in various ways, such as predicting weather, estimating holiday sales, and determining house auction prices. Processing numeric data requires a specific workflow, which can be seen in this PowerPoint slide. It is common for database to contain null values in numeric field. If there is a significant amount of data available, rows with null fields can be deleted. However, if there is not enough data, null fields are usually replaced with mean or median values. Duplicate rows in an unindexed database table must be removed. Each column in the database may have different distribution, and the min-max range may also vary across columns. Therefore, normalizing and scaling all columnar data to the same scale is necessary. Usually, data is scaled to a range of -1 to +1 or 0 to +1 to better train the algorithm. Moving on to the text database processing requires different approach. When developing an application, how you pre-process text data depends on the specific purpose of the application. For instance, a database column may have a character field with values like male and female to indicate gender. If this field is important for your model, you need to replace male with 0 and female with 1. This is because computers only understand binary data and cannot comprehend characters. This conversion process is called encoding. There are two types of encoding commonly used, label encoding and one-hot encoding. When developing a machine learning model for character-based data, such as email spam detection, a different treatment is required. If the email contains certain trigger words like lottery or winner, it must be flagged as spam while legitimate emails are not. To accomplish this, the email must be tokenized into individual words, which are considered features of the machine learning model. The number of features can be significant, especially for lengthy documents. This differs from numeric data where each column is considered a feature and the number of columns is manageable. Text data requires natural language processing for applications like spam detection, text summarization, and movie rating. Advanced applications like language translation require natural language understanding, that is NLU. For applications like fake news generation, a large vocabulary and many features are needed. In the presentation slide, we see a general workflow for processing text data. Initially, we remove all punctuation marks from the text to avoid tokenization them as features. We also remove stop words such as the, this, and at, as they do not contribute much to the document categorization or sentiment analysis. After this, we move on to feature extraction by tokenizing the document into words or sentence. Tokenizing the text into sentences is useful for summarizing a passage, while word tokenization helps identifying words with similar meaning such as run, running, ran, which can be represented as a single word run in our feature repository. This process is known as stemming. However, this is just the beginning of processing raw text. Additionally, techniques such as lemmatization, POS tagging, vectorization, chunking, chinking are required for NLP, which will be discussed in detail in upcoming video. Our next step is to analyze the data that you have just cleaned up. Presentation slide illustrates the workflow for exploratory data analysis. To analyze the data, there are various libraries available for data visualization. The most commonly used Python libraries for this purpose are matplotlib and seaborn, which offers advanced visualization techniques such as scatter plots, histograms, bar chart, pie chart, heat map, 3D plot, line plot, and contours. Also, we have polar plots and there are many more. Matplotlib can do a lot. These data visualization helps identify outliers, understand correlations, data distribution, and more. We use this information to refine our training datasets further. Moving on, we have feature engineering. Selecting suitable features while keeping the count low is crucial to train the model efficiently. This process is called feature engineering, which involves two pathways: feature selection and dimensionality reduction. Feature selection is the act of choosing specific features to include or exclude without altering them. Dimensionality reduction, on the other hand, aims to decrease the number of features by reducing their dimensions through various methods developed by researchers over time. With the help of domain knowledge, you can manually inspect and eliminate unwanted features by dropping their respective columns from the database. This could involve removing features with missing values, low variance, or high correlation. Additionally, you may utilize techniques like univariate feature selection or recursive feature elimination. You can even take advantage of sklearn's select from model to remove features whose values falls below a certain threshold. If you want to simplify your features, you can utilize dimensionality reduction techniques. One of the most popular techniques is called PCA, Principal Component Analysis. This is particularly helpful when dealing with lot of multi-collinearity or if explaining predictors is not a top concern for you. Feature engineering can be a challenging topic. I will go into more details about it in later videos on dimensionality reduction. Once you have finished selecting your features and target, you can start building your model. In machine learning, we classify problems into four major categories as shown in the PowerPoint slide. When you need to predict a specific value or target in machine learning, you use a regression model. On the other hand, classification is used to group a dataset into a known or unknown number of groups. A customer segmentation model is an example of classification. Reinforcement learning models are used when developing AI models for games that require ongoing learning, such as chess. The regression and classification model are where most of the industry's requirements lie. So let's focus on those. Both regression and classification models can undergo supervised or unsupervised learning during model training. In supervised learning, a labeled dataset is required where the target value is known for each data point. This labeled dataset allows the model to adjust its hyperparameters and prepare to predict an unknown data point. The accuracy of the model can be accessed on a validation dataset, which is part of original labeled dataset but not used during training. In unsupervised learning, there is no labeled data, or it is impractical to label the dataset due to its size. Machine learning algorithms are utilized to perform data analysis on the dataset independently. For instance, object detection models like OpenCV and YOLO were trained using unsupervised learning. As a data scientist, choosing the right algorithm can be a challenging task. There are many options available in our repositories for both regression and classification problems. Selecting the best one for the dataset and achieving high accuracy can be tricky. The presentation slide is for a quick overview to see the numerous algorithms available for machine learning. It is crucial for the data scientist to comprehend this algorithm or at the very least understand their concept. By understanding the purpose, you will know which one to use for your current needs. Efficient developers have already implemented this algorithm, and it is unlikely that you will do a better job than them. Even if the implementation isn't fully optimized, it's typically satisfactory. Most libraries in the market provide optimized coding, so high-level optimization is only necessary for real-time inferences. With the advancement of technology, there is now a way to get help with selecting the best algorithms for your needs. This helpful tool is called AutoML, and it is available in several libraries and frameworks, both free and commercial. One open source library that is particularly popular is AutoScaler. This libraries and framework can automatically prepare your data, choose the best machine learning model for your dataset, and adjust hyperparameters for optimal performance. Essentially, they take care of the entire machine learning process. All you need to do is provide them with your dataset and they will suggest the best performing model, which will be fine-tuned and ready for use in production. They rank the model on accuracy and you can choose the one that best suits your need. Currently, major tech companies like Google, Microsoft, and Amazon offers machine learning as a service. This allows users to upload their dataset onto servers and receive a model pipeline that can be accessed through a web service. However, relying solely on these automated services may not be suitable for a true data scientist who prefer to have more control over the model development process. To supplement your own data science efforts, you can utilize free libraries such as AutoScaler, AutoKeras, or commercial version of H2O.ai. These libraries will train model on your dataset, evaluate their performance, and rank them based on accuracy score. This can be a helpful tool for narrowing down your model selection. Furthermore, some AutoML libraries like BlobCity even provides a full source code for model building. This can be particularly useful for those who want to fine-tune parameters and have more control over the development process. After selecting an algorithm, the next step is to fine-tune its hyperparameters. Each algorithm has several parameters that require fine-tuning, known as hyperparameter tuning. This process is iterative and involves evaluating the model's accuracy score on the validation dataset. You can use frameworks like Optuna for hyperparameter optimization. Once you achieve the desired level of accuracy, the model is ready for production use. The workflows I have demonstrated so far are for creating machine learning model based on statistical modeling. In the next video, which will be the part 2 of this video, I will outline a workflow for developing models using neural networks. So please subscribe to my channel and I will see you in my next video.